Number 14, let's look into Julio's life here. Julio is saving for a vacation. He wants to go on a cruise with some of his buddies, and he needs about $3,000. Okay. He currently has $750. Okay, so he needs a lot more money than this. And he puts it into an account with 2.3 interest that compounds monthly. So how long is it going to take for Julio to save enough money for his vacation? So we've answered questions like this before, but usually we would answer for the final amount because we didn't currently have a way to solve for an exponent. But now, thanks to logarithms, we can solve for that exponent. But we need to remember that this equation is the one that we use to compound monthly. So if it said compound continuously, we would do like we did in number 12, a equals pe to the rt, but we can't do that because we only are compounding monthly. The continuously equation would give us a decent estimate, but it would not give us a perfect estimate. So he wants to end with $3,000. You have to know where to put these variables, and then the solving we can do. But we first have to get everything in the right place. He starts with 750, and then his interest rate is 0.023. Okay. So 0.2 would be 20%. It's 2.3%. And then we have to divide it by something. Well, what is n? N is the number of months in a year. Okay. We divide it by 12 because this is a yearly interest rate, and we're doing it monthly though. So we're going to divide it into 12 pieces, and then n in the exponent is also 12, and we don't know what t is. So that's the last thing we're going to do is we're going to solve for t. If we divide by 750, we get 4 is equal to 1 plus 0.023 over 12 to the 12t. And so now we can rewrite that as a logarithm with a different base. So the base of the exponent is always the base. This is just a number, but since I don't know that number, I'll just write it as I have it there. So the log base, this growth rate of 4 is equal to, remember the log is equal to an exponent, log is equal to our exponent, 12t. So once we do the log base this of 4, we'll divide it by 12. So let's run to the calculator. You get math, you can go up twice, you get log base, and what's our base? It's 1 plus 0.023 divided by 12 of 4, and then we divide that by 12, and we get t. Okay, so now let's look at what this means for old Julio. T is 60.3. 60.3 what? Well, the number of times that we compound is 12 per month times the number of years it takes. So this number is in years. So I don't know how old Julio and his buddies are, but cry face emoji, 60.3 years to go from $750 to $300 at 2.3% interest compounding monthly. It takes money to make money, people, and Julio doesn't have enough of it. So I'm going to just write a little message that says, keep working, Julio. Perhaps get a second job. You're going to have to put more money in this account to get enough money to have a vacation before, or at a point in your life when you can enjoy this vacation. So there's Julio. Let's see if we can get 16 and 18 at least in this video. Number 16, population of a long-haired rabbit triples every month. The number n of rabbits presents the number n of rabbits present after t months is modeled by t equals log base n 3 of n. So when will there be 243 rabbits? Okay, so where do we put this 243? Number n of rabbits. and it says when, so that would still be our variable. So our variable is t, and so this one really is as easy as it looks. What's the log base 3 of 243? And if you have your cool little half sheet, you don't even have to type that in your calculator. You will know that 3 to the 5th power is 243. Because what this literally means, this logarithm says, what power do I raise 3 to get 243? And so we know that t equals 5, and t is a number of months. So in 5 months, you'll have 243 rabbits. Number 18. We've got this equation that models the relationship between altitude and pressure. So H is altitude above sea level in meters. P is pressure in kilopascals. Then it says the average person begins exhibiting the effects of oxygen deprivation around 3,000 meters. What is the pressure at that altitude? Okay, so they tell us a height in meters. They tell us, let's circle that, 3,000 is the height, and that's equal to 32,900 minus 7124 times the natural log of p. So now we need to solve for p. First step, subtract 32,900. I'll just pull up my calculator. So 3,000 minus 32,900, didn't really need that calculator, negative 29,900 is equal to negative 7124 times the natural log of p. Now let's divide by negative 7124. And I get that, let's go over here, the natural log of p is equal to about 4.197. So then, to solve this, we would rewrite it in exponential form. So whatever the base is always the base. The natural log has a base of e. So e to the 4.197 power is p. So what is p? Do e to that power, and we get that the pressure is about, let's see, round your answer to the nearest kilopascal. So it's 66.49. So if I'm rounding that to the nearest kilopascal, I'll have to round it down to 66. 66 kilopascals. Stop there. Another video will start with number 20.